Unit 5, Section 2, Properties of Parallelograms with a slight Lord of the Rings theme. How cool is that? It's a little cool. Let's be honest. Those kids in the other classes, they don't have a picture of Brust looking like this. Come on now. This is fun stuff. Parallelograms. You might ask, what is a parallelogram? Look, I drew a kind of a haphazard parallelogram here for you. A parallelogram is a quadrilateral that has both pair of opposite sides parallel. Okay, so that means that in this figure, the top and the bottom are parallel to each other, and the left and the right are parallel to each other. But what else happens when the sides are parallel like that in a quadrilateral? So we have 4 different theorems. You might have to pause the video as I explain these theorems so you can write it down. You're expected to write down the theorem and the visual representation, which is basically a picture that shows what's going on with the theorem. So let's start with the first one. Okay, the first theorem, if a quadrilateral is a parallelogram, then its opposite sides are congruent. Pause the video. Okay, you're back. Opposite sides congruent. That's pretty easy enough to understand. I mean, if this side is 10 here, then the other side we know is also 10. All right, same thing for the blue sides. If one is like 8, then the other would be 8. They're basically the same. That's the easiest one to understand, I believe. Something a little more complicated. Pause the video, write it down. Okay, you're back. If a quadrilateral is a parallelogram, then its diagonals bisect each other. Now, if you remember what bisect means intersect at the midpoint, and the midpoint divides the segment into 2 congruent halves. So, long story short, they're cutting each other in half. Okay, the blue diagonal, do we know what a diagonal is? I didn't spend time explaining that, but a diagonal goes across the interior of the polygon. Okay, so we have this whole DB is the diagonal, and it is cut by AC, and AC is also cut by DB. They cut each other into 2 congruent halves. So let's play pretend. I love playing pretend here. So if this is 8, what is EB? If DE is equal to 8, EB also equals 8. All right, what about DB? Line segment DB would equal 16. It's 8 plus 8. Okay, how about on the other side? You'd have to come up with another measurement, but maybe it equals like 20. Okay, so if this side equals 20, AE, then EC also equals 20, and AC would then equal 40. Okay, so that is the second theorem. That one's not too difficult to understand. Let's go to the third one. Third one is pretty easy. In a quadrilateral, if it's a parallelogram, then the opposite angles are congruent. Okay, so opposite in a parallelogram. Okay, so let's pretend like we're talking about this one marked angle here. The other one marked angle is up here. That's opposite. The angles with 2 marks, they're called consecutive because they come one right after another. If you go around the parallelogram, you're going around in a circle here. After 70, what comes next? That's a consecutive angle. Okay, so opposite means not consecutive, but it's across the quadrilateral over there. In this case, across the parallelogram. So basically, if this angle here equals 70, the opposite one also equals 70. All right, what about this angle? If this equals 110, the opposite angle is across. So this would also equal 110. And if you notice, 70 and 110, that's peculiar. Here's another theorem. If a quadrilateral is a parallelogram, then its consecutive angles are supplementary. So any 2 angles that come one after the other as you're going around the parallelogram, doesn't matter which way you go, 2 angles consecutive, they are supplementary, and you remember that equals, when you add them, their sum equals 180 degrees. By the way, I'm going to show you a little trick now. I'm not sure if I showed this yet. Some students get confused. This is a little side note, so pause. Some students get confused between the difference of complementary and supplementary. So I'm going to show you the difference right now. Complementary starts with a C. Supplementary starts with an S. That C you can make into, ta-da, 90 degrees. That S you can make into, ta-da, 180 degrees. That's how you remember the difference between supplementary and complementary, so that you don't get your mastery checks wrong. A little trick. I'm going to go back to my theorems now. My precious, precious theorems. Precious! Wow. Schmiegelbrust. That was crazy, you're precious. All right, so you have your precious theorems. You're precious. And what we're going to do is use those theorems to solve for x. We love x here. X is one of our favorite variables. All right, so I'm going to warn you, you have to be careful. In our figures, sometimes it's difficult to see, but in the number 1 here, we have, that's this angle here, 22x minus 2. Okay, that's angle V. All right, that's not angle W. So just be careful when you're looking at these figures that you don't get the wrong one. So find x in each parallelogram figure. So what do we know about this one? This is the what? Let's see, which, these are consecutive. Let's see, that's this one here. Consecutive angles are supplementary, right, Schmiegelbrust? That's correct. Supplementary means that they add to 180 degrees, so we're going to write that out. 22x minus 2 plus the other angle, 94. That should all equal 180. All right, so now this is simple. We just have to do some algebra. So 22x, we're going to combine like terms. Negative 2 plus 94 is a positive 92. All right, so that should all equal 180. What else now? Subtract 92. We're so good at this now because we had flip mastery algebra. All right, so 22x equals 88. We divide by 22 each side. What do we get? 88, 22, x equals 4. And they wanted us to solve for x, so guess what? We're all done with that one. Wee-hoo! Let's do number 2. Okay, number 2 was the first theorem. The opposite sides are congruent. Well, congruent means the same, so LM has the same measure as KN. So what does that mean? That means that 17, which is, by the way, Sully's favorite magazine, is equal to x plus 7. All right, so we just have to solve that equation. If you can't solve this equation, you should back up and go back to algebra, because this is a simple equation. You get x equals 10. All done. Let's do number 3. 3 is a little bit different because it says find the measure of angle K. Now, they've drawn a diagonal down the middle of the parallelogram here, and this angle has been divided into 2 parts, 34 degrees and 12x plus 4. That entire angle here is consecutive with M. Okay, I need to undo that because I'm not going to be able to see whatever I wrote right there. All right, but it's consecutive with M. There you go, Bulldog. So that means that this entire angle plus M equals 180 degrees. All right, so let me write that out. So angle MLK plus angle M equals 180 degrees. All right, angle MLK, what is that? That's this angle down here, bottom right. That is 12x plus 4 plus the other angle, 34. That's angle MLK. Okay, angle M, we can substitute 24x minus 2. And all of this equals, running out of the room, 180 degrees. Well, now it's just a combined like term party. Here we go. Combine some like terms. 12x, 24x, that's 36x. And we have 4 plus 34, that's 38, minus 2 is positive 36. All of that equals 180. Subtract 36. How's your mental math? They cancel. 36x, that gets brought down. All right, 180 minus 36. Let's subtract 30, and then we'll subtract 6. So if you subtract 30, you get 150. If you subtract 6 more, that'll leave you with 144. All right, so now we divide each side by 36. Can you take a guess about what that is? Think, try to guess. It's 4. All right. Ta-da. Are we done? Did I box it? You know why? Because it says find the measure of angle K. Angle K is down here. K is the same measure as M. So guess what we have to do? We have to find the measure of angle M, which is 24x minus 2. That's what angle M equals. And we know that x equals 4, so it's 24 times 4 minus 2, and 24 times 4 we know is 96. Subtract 2, so all this equals 94 degrees. That's what angle M is, and we know that angle K is also the same measure as angle M because they're opposite from each other. All right, so angle K, this is what angle M equals. I like to be, write it all out. So this also equals angle K. All right, 94 degrees. Ta-da! Did you follow that? They want to know the measure of angle K, so we need to find out the measure of angle M. And we solve for X, we plug it in. Voila, that's so easy! But guess what? What's not easy is if you don't learn these theorems. So my question, Brust plus Gandalf, is that Brustolf or is that Gandalst? I don't know. But either way, you shall not pass. If you don't know these theorems, you will not pass the mastery check. We have 2 more here. All right, so number 4. 4 is easy. Look at that. Doesn't get any easier than this. Opposite angles, they're congruent. So let's set it up. 72x plus 2 equals 146. We subtract 2 from each side. They cancel. Remember our little equal sign here. We get 72x equals 144. We divide each side by 72. I know I'm going quick here, but we should know how to do algebra, and we should know how to solve these equations by now. 5 is a little bit tricky. It's a new type. We have RF. All right, so RF. Let me do some highlighting here. Got to use my highlighter. RF is from here to here. And RT, they also give us, that is the entire way. They're not equal to each other. Sometimes they'll give you RF and FT, all right, and they would be equal. So you set them equal to each other, solve, solve, solve. This time, though, they don't do that. They give you RF and then RT. So you have to be careful. What do we know about these two? Well, the green one is twice as big as the yellow one. Or the green one, which one is the green one? RT here. So I'm just going to write a little equation. RT is twice as big as RF, right? So if RT is twice as big as RF, let's just substitute in. So that means that 26x is twice as big as 12x plus 1. Please make sure you use parentheses here. It's twice as big as the entire quantity of RF, which is 12x plus 1. Check that out. I almost made a mistake. So now what do? We distribute. That is correct. So 26x equals 24x plus 2. And what are we going to do? Now, some students, their natural instinct is to subtract 2 from both sides. But look, that doesn't help anything. Okay, you have variables on this side, variables and numbers on this side. You need to get rid of this variable term right here. So how do you get rid of a positive 24x? You subtract 24x from each side. Ta-da! All right, so what do we get? 2x equals, they cancel, 2. Hey, look at that, x equals 1. So if you notice, some problems that ask you to solve for x. Some problems, if we go back, it asks you to find an actual angle, or it might ask you to find like a line segment. You have to take your answer and then plug it in. Please be extra careful when you're solving these problems that if it wants you to find an angle or a segment length, that you actually plug it back in and do that. Okay, so here's the last 2. You try these all by yourself. I'll figure them out, you figure them out, and we'll see how we do. All right, pause the video. Okay, how do we do? Did you notice on 5 you have consecutive angles here? So they must equal 180. I'm talking about 95 degrees with this entire angle RST. Okay, that whole angle plus 95, they're consecutive angles of the parallelogram. I'm not thinking the diagonal right now. Just 95 in this angle up here. All right, so I need to add, it's the angle addition postulate. I need to add these 2 angles together to get angle RST. So that's what our equation is going to say. 95 plus these 2 angles together should equal 180 degrees. That's our equation. Add them together. Voila, x equals 6. That's how you do that one. For 6, we have 2 diagonals here. Well, one of them's bisected they're bisected, okay, by each other. And we get 6x minus 3 equals 5x. That is very simple. You solve it, you get x equals 3, but they want FW, so you have to plug that 3 into 5x, and you get 15. Hey, you're all done. Let's see, Aragon, Parrallelogram. That's who it is. Parrallelogram is here to solve all of your problems. This is Mr. Kelly and Baumholder. Remember, It's nice to be important, but it's more important to be nice. So.